Welcome everyone to our distinguished webinar on Artificial Intelligence and Cybersecurity. Today's presentation is titled Language-Based Approaches for Modern Malware Analysis and Classification, featuring Dr. Phung, an Associate Professor and Director of Intelligent System Security Lab in the Department of Computer Science at the University of Dayton, where he served as Interim Department Chair in 2022 to 2023. He's also the point of contact of the NSA National Centers of Academic Excellence in Cyber Defense at the University of Dayton. He's been a visiting associate professor at Ohio State University in the fall of 2023 and a visiting scholar at the University of Cincinnati in the spring of 2024. Dr. Phung's research focuses on security solutions for intelligent web, mobile, Internet of Things, in-vehicle systems, and potentially malicious software, which has been published in the prestigious cybersecurity journals and conferences. His research has been funded by the Swedish Research Council, NSF, Ohio Department of Higher Education via ORCI, and Novobi LLC. Dr. Phung is an associate editor for 2 journals. He's been a reviewer for many top cybersecurity journals and conferences, and has served as a program committee for over 20 international conferences. Dr. Phung is a senior member of IEEE and ACM and has been invited to speak at many reputable institutions and industry and academic venues. Dr. Phung, it's a pleasure to have you here. And with that, I'll hand it off to you.
Yeah. So thank you so much for introduction and also for the opportunity to present my work. So let me share my screen to start my presentation. All right. So let me turn up another computer. All right. So everyone can see me okay? Yeah.
Yes, we can.
All right. So today I will present some of my research that doing like applying machine learning and AI in malware analysis in cybersecurity. And the approach is based on technique called language-based security. Before I go into more detail about the approach and the work, I want to provide an overview of the topic. So first, I want to review malware analysis and classification. And I assume that everyone familiar with this topic. However, I just provide general information just in case you are not familiar with. So before we do the machine learning, traditionally, there's a software, antivirus software, for example, they will detect the malware, but the approach normally is based on static analysis that they will analyze some signatures and patterns and compare with some null malware samples. However, most of the modern malware can bypass this because they can try to do another way to bypass this checking. The next approach is based on machine learning. So typically, I'm talking about supervised machine learning, where we deploy some of analysis method on very large scale data sets and with labels. So for example, the data sets already labeled by security expert that they they're not classified, they already say, hey, this sample is benign, this sample is malicious. And based on that analysis, they will extract the features, and then they will use a machine learning algorithm uh, to um, to to classify whether uh, the sample is like yes or no, and malicious or not. So this picture show you the the one that I just mentioned, right? So we have input, and we have typically some data engineering to extract the features, and then we feed it into a classification network, machine learning, and then we have a result. Typically, I mean, depend on the domain. Every step in this picture is important, right? However, in securities, in my opinion, I think the analysis ones, the method to analyze the code is one of the most important step here. So in the domain of machine learning based classification, we classify that into two time of the analysis, or maybe three time if you can see the picture here. Right? Like static analysis, dynamic analysis. That is two typical one. However, sometimes uh, people researcher combine the two together. It's called hybrid analysis. And if you see here, the dynamic analysis is like have a more attention, right? So what are the challenges of these? Why I talk that like the analysis is challenge because there's like the first thing is that when we do the analysis, when we do the feature extraction, um, typically we need some expert domain knowledge to to review to to SMI the samples to make sure that okay we know the useful information over there. And the issue is the challenge is the modern malware nowadays they have a lot of techniques to overcome this analysis. So for example, they have a obfuscation technique, they have a backing technique, they have encrypting technique, and many other advanced evading techniques. So for example, the idea is that they have the same sample, same family of malware, but they create a new variant of the malware so that they can hide the activity, the malicious activity. So here is an example that I will revisit later. So for example, the code here is the traditional, like the original code, but when they write the malware, they do not write this one, but they write in the B. You see here is in the sense that it will bypass. Of course, you see if we do the static analysis, B will be different from A, but actually they are the same semantic. Or I have another example that I just have an overview. Like for example, they have a code obfuscation using that code injection, or they have code transformation, or instruction substitution, something like that, right? So it's a lot of technique that the malware, the modern malware, they uh, they already done in practice. So our research motivation, the motivation for our research is that we want to provide an analysis method that can overcome this challenge, right? Um, in the other hand, we want to provide as much as possible the useful features for machine learning model that also, we mentioned the challenge before that we don't need to rely on security expert, and we still can capture the malicious behavior or malicious activity. Even the malware already have the evading techniques, right? So the approach that we study here is that we use the language-based security uh, discipline. And that is the way that we want to adopt in this type of research. So if you are not familiar with language-based security, I just give you an overview here, but I maybe you already familiar with this already. Um, the name of this suggests that we use a language. So language here is a programming language because software developed by a programming language, right? So in language-based security, the way we want to study or we want to measure the security that we look into the application level because the application written in that level. So with that, we will ensure, for example, the time, memory safety. We ensure the access control. We ensure the data flow, uh, uh, and all the safety and security. Um, in more detail, this technique will look into the program in two ways. The first way is that before the execution, they do the analysis of the code to ensure that the code is safe. And secondly, we can rewrite the code so that if the code is harm to the system, then we can avoid that because we can rewrite the code. Or during the execution, we can also monitor the behavior. And if the behavior violates some security policy, we can stop that behavior, or we can audit the code to have a policy action. All right, so I provide an overview and introduction about the um, the research and our motivation and the language-based approaches. So I will move to one of the work and I will focus mostly for the rest of the talk. Um, I'm not sure if we allow the question during this talk or we will um, say at the end, but I'm open to everyone. Jamison,
Yeah, we usually do Q&A at the end because panelists can't unmute themselves.
okay, yeah, yeah. So that's good. So this is the so by the way, a little bit different, not different, but different order in my abstract that I focus on the JavaScript code for Melissa's website before the Java bytecode. And I focus mostly on the JavaScript as is interesting and an ongoing work that I'm doing right now. So before I jump into the approach and the research I'm doing, I want to review some of the terminology and the concept here. So why malicious web is still important, and I provide you some of the report here. You see that the malicious web is still going on and going on, right? And it's just last year you see that the web attack are like double each year, right? So it's still the serious problem because we need the attackers try to bypass all of the mechanism that we have, even a lot of mechanism already deployed in practice. For example, Google safe browsing is still there, and they continue blacklist website. You see here it's 10K website per day. However, it's still going on, right? Um, so typically, these malicious web are classified by, for example, drive-by download that they will automatically deliver or install the malicious software. Or of course, the phishing is another one, or some malicious ad that they can corrupt the information from the end user. The challenge of the malicious web compared with traditional malware is that the uh, the attacker do not come to the to the victim. But typically, the victim visits the attacker, right? Because you visit the website, so you get attacked. And the question is how this happened and how the malicious website work, right? So typically, the web attacker will develop and control some malicious website, for example, attacker.com. And in that, they have some malicious code. And then they will do some, attack. For example, they can retrieve the stolen information or something like that, right? So it's different from no other attack, as I say. The victim visits the attacker, and the web attacker have no access to the victim machine, right? That is the way. So, for example, the attacker click on something, phishing email or whatsoever, or the visitor or the victim visits some trusted website, but in that trusted website, they may include a code from the attacker due to some, for example, some vulnerability or some security flaws. For example, I mentioned here Reuters.com was a case like about decade before that where the user visit Reuters.com, they get attacked by a malicious JavaScript advertisement, right? And um, technically, how attacker develop malicious website is similar to another web development, right? The attacker typically develop a website, but different from legitimate that they will do um, some some malicious behavior. I want to note here that the because this is in a web attack, right? So the challenge and the difference here is that the code will develop at the and store at the server side. However, it will be executed at the client side. It means that the the code will download and run in the browser, in the victim browser, right? And the language that is used for this is JavaScript. If you familiar with the web, right? So JavaScript nowadays is like it's used by like you see that almost 99% of on websites nowadays, right? And you may or you may not know that JavaScript used to a language that developed like really uh, just in 10 days in 1995. It's a long time back, right? But it's developed by just individual. Later on, it's become a community project, uh, and now they you see that is the most popular on the web. All right. Um, so so for this, I would like to highlight some of the key features of JavaScript. If you are not familiar with. Um, so JavaScript is very different from other language, other programming language is that they have a like they um, they have an interpretation. The source code is available because the browser need to load the code and run the code. Um, and it's with that, it's a platform independent because it's run in the browser instead of on the operating system, right? So that is another challenge of the protection because, for example, the antivirus software they cannot look into the browser to detect the, the problem, right? And another very convenient feature for the developer, but it's also the good thing for the attacker is that JavaScript is a dynamic language that the code can be executed on the fly. It means that the code can be loaded uh, during runtime and add it into the code and run it and then generate the content, right? And the code can be written in string and executed dynamically. That is the very interesting invention of the language, but also it's also the dangers features of the language. And of course, because of that, the new code can be generated and executed, right? And I give you some example later. So with these features, JavaScript become very challenging for the security and especially for malware analysis with this. Um, Static analysis, as I mentioned before, is one of the method that they can researcher can deploy to, for example, to extract some feature using, for example, the structure of the code or abstract syntax tree of the code, or they can abstract some string and object or functions. And if I give you some example here that is not a new problem. However, it's still have extension from the research community. So, for example, I give you one work that is like in 2010, but it's just another work still in this year, and it's you see that it's almost a 3,000 article if you search on Google Scholar. Studied analysis have advantage that because they do not need to run the code and they can extract the code, right? However, there are some challenge that the studied analysis fail. For example, as I mentioned before, JavaScript code is a dynamic language so that they can generate a new code based on some event, or they can have some evasion technique that the attacker can use to hide the malicious. I give you one example, right? So here is example. Document write is like similar to print, right? So it's print something, and if you can see here, it's print something, print something, print something, print something. But when it's run, it will be something like this. So it will create another code at runtime. So this is one example of dynamic code generation. Or another example is, let's say we have a JavaScript code like this, and it's doing like this. But the attacker can also do it like this, and it's similar. You can understand this one, right? At the developer, you can understand this one. But let's say if you read like this, you cannot understand anything, right? At the the developer. However, this is equivalent code. So these are the challenges that JavaScript base in the static analysis, and even if we do computer analysis, right? This will be really challenging. And another example of this, including a lot of technique that already deployed in JavaScript. And recently, there's a research um, do analysis of the obfuscation techniques, and they conclude that the JavaScript detector provide not a good, analysis in the obfuscated sample. So, for example, they provide a very high false negative and very high false positive as well, right? So that is one. The other is dynamic analysis that they will run the code, right? However, the dynamic also have a challenge. So, for example, they have a like overhead, and maybe some of the code can have a like the so if they because they run the code, and the code can also detect that okay there is the code that running, so they can change the behavior so that the code um cannot do the cannot detect the analysis. All right. So that is the overview of dynamic analysis and static analysis and the challenge that that we have. So I want to move to the approach that we use a language-based security in JavaScript in general, not yet in this domain. So in the past, we developed this approach to JavaScript security by a behavioral sandbox to monitor the behavior of the JavaScript code. And the idea is that if you have a code like this, we will have a sandbox around the code so that we can, uh, the idea is that we can wrap the sensitive execution. So for example, the method call or the property access. An example of this I provide that let's say we come back with the hello the alert that I showed you before, right? So the idea we do is that we will we will keep the original to that, and then we rewrite the code so that when the code will run, it will go to our code, not to the original one. And with this, we will do some security checking, right? So we'll do some security checking to make sure that the policy, the code running is not violate security security policy. All right. So um, maybe let me skip this. So this is, as I mentioned, this is just the work that we have done fully in JavaScript security, and we have couple of prototype um, that we try to secure the web. And one prototype that I will present next that related to the work that I mentioned is that we develop a browser extension using this technique, and that browser extension called MyWebGar, and we published a couple of years ago. Um, all right, so in this browser extension, what we are doing is that we provide the sandbox, the behavioral sandbox in JavaScript library, and then we deploy that at the browser extension to monitor the code behavior. So we will intercept the code at the library, and then we can provide some data protection. For example, if the data from sensitive data from the source go to the data sink, then um, we can prevent that happen. And in the work, come back to the work of the analysis, JavaScript analysis, we apply this technique into JavaScript analysis so that we can do the we can use the machine learning for malware website malicious website classification, right? So the idea we have done is that we deploy the sandbox into browser, and currently, as I mentioned, we implement that the browser extension. I mean, in principle, we can implement inside the browser, or we can implement by a proxy browser server, something like that, right? So the idea is that when we have that in the browser, whenever the website log, we will run the code as usual. But instead of um, we control the behavior of the website, we just log the behavior. For example, we extract the API call or the execution of any behavior in the website. Uh, so because we capture the behavior, whatever the code is written, it doesn't matter, right? Because if you use any dynamic code generation or you use a obfuscation code or whatsoever, it will not matter because we capture the reference to the API call, right? So here is one example that we are doing here that we try uh, um, to log and we record the number of the execution in JavaScript. So here is one example. we capture one of this one, and then we log in this, and then we count the number of the execution for this API, and these features will be used for the machine learning. So in next slide, I show you the framework that we are using, right? So we have a sample of websites. So I show you later that we have currently we have a 22,000 records of malicious website and benign website. So we will develop a tool. We already developed a tool that we run this website automatically inside the browser, so that we have the browser uh, up and run, and then every website run, we will extract a feature. We store into a database. So the database, it's just the CSV file, and then we use this CSV file to have a machine learning analysis, right? Um, and currently, we have um, we do the experiment here, and I want to show you like a 1 minute demo uh, that we mentioned here. Right. So let me say. You still see my screenshot, right?
Yes, we can see it.
So let me start with this first. Yeah, so you see here, like the script will be open the browser, and then when the browser is open, um, it will um, it will run the website, and when the website is running, then behind the scene we extract the features, and then we store into a um, into a CSV file. You see the CSV file is generated here. Um, Yeah. So these are some website, and this is the output that we provided. You see the output is running like this. So this is the output that we provide the features, and then of course the next step is we run the machine learning model on these features. Okay. So that is uh, overview of one of the approach that um, we have been doing, and we still doing further experiment to this is based on two master thesis that I suppose I will mention later, and still not published yet, so we're still working on it. All right. I Next, I want to highlight maybe just a few minutes about another similar work that we done before, and this work already published a couple of years before. Uh, we also use a language-based approach that we apply for Java bytecode, and the idea of this method is that we use the tool to analyze the code. We do not run the code, but we analyze code. However, in here, we will look into a API. Similarly, we look into the API call for the Java bytecode. And then we will create at the end, we create image, the grayscale image. The reason we create a grayscale image because the machine learning, the CNN network classification is good for image based, and then we will use the classification. Additionally, we also use some static behavioral features to add into this image so that we can increase the accuracy of the method. So how we create the image? We use the it's called the information inter-procedure flow control flow graph. So the control flow graph mean like if we have a function A called function B called function C, we will model that into the adjacency matrix, and then from the adjacency matrix, we will map it into a grayscale image. And in the second one, we have uh, the set of the another features to add into this image. All right. I also want to highlight and I give you an example of the control flow graph here. So the idea of this bytecode transformation is that we will capture the execution order. Um, so so the step is that we will put the node and the sequence of the program instruction. So one API will be one node, right? And then it will be um, I provide you an example here and I come back. You see, so we will start here and then whatever the API call, it will go into this, and this is the first step. And then the second step is that we um, this step is this is the graphic visualization, but we put it into the structure like this. It's a dot file like this, and from this dot file we create the image, right? And additionally, as I mentioned, we also use the additional features as well. Um, so in this, we had the experiment in about 4,000 samples of Java. So it's Java bytecode, right? And we run the method with our CNN network classifier, and we have a different um, uh, settings. And if you can see here, we have like this basic one, and we have a single lot CNN structure, and we have a double lot. And if you see here, we compare our method other um, with other approach. That you see our method is like outperform. For example, here it's 98.4% compared with other baseline um, method that is have a similar thing. All right. So I think that is mostly my presentation. I have some remarks and future works, but I see some of the Q&A question here, so maybe uh, I will go
We can
to
either,
answer.
if you want to field questions now, I can start off.
Yeah,
Also, if you want to finish your presentation first, that
yeah.
will.
I would like to have a Q&A now, and then
Okay.
I will say maybe 2 or 3 minutes for the concluding remarks.
Okay. Dr. Otrukose asks, what can be done to further for language models to enhance them specifically for malware analysis? Do language models tend to be enough, or do we need something more specific?
Um, okay, so can we done for further language model for malware analysis? Okay, so I think that is beyond of my research appetite, because I typically I'm working on the I think that is a good question, and also that is the direction of the future research, right? So right now, the challenge that I want to solve here is that some of the the like malware technique, they try to invade the analysis technique. But there is another way that okay, they also want to evade the language model as well, right? But I do not have a study on that yet. So I do not have an answer that okay, um, this language model should be improved to enhance the security analysis, malware analysis. Um, I I do not have an answer about like the language model have enough what we need. So maybe that is another direction of the collaboration that, um, for example, we can try to so in the work that I present before, like the malware analysis of the web, we try to run different models, and different model have different accuracy, right? But we do not investigate why is have a different accuracy, right? Uh, so back to that, I would like to explore further.
Okay,
Yeah.
thank you. Then we have Dave Loper asks, in addition to the ISSE Collab U Dayton WebGuard, uh, are there any other repositories with the source code, and do you have plans to make it available in the Chrome extension library?
Um, right. So yeah, that is the code that we publish our first version. Um, I think we also have a second version and a third version of this. Um, that I'm not sure is public or not yet, but yeah, but right now we so yeah, right now we still, as I said, we still working on it, right? So the idea behind this is that we will try to um, the next step is um, we will revise this in the Chrome extension. Um, and I mean, we didn't plan to make it in the Chrome extension library yet. The idea that we want to do is that we want to implement this idea into the like Chrome browser itself. So so that is the idea, and we will not publish for the user. So the idea of this is we try to build a browser for a security expert to do the malware analysis or to do um, um, the digital forensics, in malware analysis on that way.
Okay, thank you. I had another question. In the part one JavaScript language-based analysis, you
Yeah,
have the code running on a virtual machine, and then what are you
yeah.
using as your features for the CNN?
Yeah, so okay, thank you for that question. So we have a 45 features right now. Um I'm not sure if I have the table here, so let me see. Yeah, I think I have some feature here, right? So here are some features that we do the feature important, and basically these are the features that is typically is the API call from JavaScript, and we have a 45 of them. Um, and this is also, another improvement that we try to do. Maybe we can add more feature, more API call for uh, higher accuracy. Yeah.
What
That
is
answer your question?
yeah, I guess what is your rationale for doing, so this is API call, and I guess the alternative that I would see is doing like you do in the Java bytecode machine instruction sequence. And is it this just it's more efficient or
So yeah, so that is yeah, that is then that is the one that I have in conclusion remark. So um, yeah, and thank you for the question. So the idea is that the one that I present to you is just a preliminary result, right? And we're still working on that. But I feel like we do some experiment to the idea behind the scene is that we try to make sure that we can overcome the obfuscation techniques and any evasion techniques, right? So the next question is what kind of feature is better? And we still, do the further exploration. And at you mentioned, I think the idea that we use, for example, the control flow graph maybe and will provide better for language, models. And we're still working on it, right? Uh, so yeah, so that answer your question.
Oh, yeah. Thank you.
Yeah, yeah. And so since we come back to this one, I want to have a last slide about the future work that I think is also cover the question that we discussed before, that about language model, right? So we want to try, different way how we can provide a better future for language model, machine learning models. But I mean, like Dr. Coase asked, maybe we can also, collaborate to study about, okay, if the language model is sufficient enough, or maybe we can do something else, right? Additionally, in JavaScript, especially in JavaScript, there's a new technique. Actually, it's like a couple of years old, but I don't know if you heard that WebAssembly is another, language for the web, and malicious, the attacker already use this to bypass, machine learning model, and we try to learn that as well. Um, and related to the question that Dave asked, is that we try to implement that the browser as a tool for security expert or data scientists to use. Another the question that Dave asked is that whether we make this available at the Chrome extension library. Um, the question is yes. However, that will be different work that we try to um, just protect the internet user, the web user, and we have a core framework. However, the application are different, and we're still working on that. We're still working on that domain. Um, so here, um, uh, two master thesis I mentioned um, that I present this, and I have acknowledgement to my students, and also the work that I mentioned about Java bytecode collaborate with other um, um, uh, collaborators, external collaborators. All
Thank you,
right.
Dr. Phung.
Yeah.
Um, does that conclude your? Oh, go ahead.
Yeah. Yeah. So I'm done. So I just um, if you have any more question, I believe we still have few minutes. Um,
Yep. For right now, it looks like we got through the Q&A. Maybe a few will pop up here, but thank you for your great presentation. I'm sure we'll be in touch in the future. You'll also be receiving a plaque and a certificate signed by our dean for contributing to our webinar on artificial intelligence and cybersecurity. Do you have any last comments on your work?
no, so I think that I try to present this is the ongoing work as well, and as I say, I looking forward to have further discussion as well as the collaboration. And I thank you again for the opportunity to present to your institution. and I expect to get in touch with your school for further collaboration. Right.
That sounds good. Okay, well, I don't see anything in the Q&A, so we can conclude 10 minutes early. Thank you for your time.
Oh, I thought you planned for 50 minutes. So
Oh, they usually do go to noon, but yes, our flyer says 11 to 11:50.
yeah.
Yep.
So yeah, I have a couple of slides, but I mean it's okay. I cover almost everything. Okay.
Okay.
Yeah. Right.
Very interesting work.
Yeah.
Have a
Yeah.
good
Thank
day.
you. Thank you. Bye.